Imagine a world where simply looking up at the sky could be seen as an act of rebellion, a time when questioning the established order wasn't just risky, it could cost you your freedom, or even your life. In this world, the universe was viewed as unchangeable, with the Earth at its center and the heavens above considered perfect and unmovable. But then came one man with a bold idea and an even bolder action. He took a simple tube with lenses, pointed it toward the stars, and forever altered our understanding of the cosmos. That man was Galileo Galilei, and his discoveries reshaped the very foundation of science and how we perceive our place in the universe. Now here's the hook. What if I told you that you're using a modern version of Galileo's groundbreaking invention every day? That's right, your smartphone camera is a direct descendant of Galileo's telescope. It all started with that simple device, yet it opened a gateway to the stars and changed the course of history. In today's video, we'll dive deep into how this single invention, combined with one man's courage to defy the norms, rewrote not just the books of science, but the way humanity sees the cosmos. So, if you're as fascinated by the stars as Galileo was, make sure to hit the like button and subscribe to Exploring the Universe to keep following this journey through time and space. Let's explore the unknown together. Galileo Galilei was born on February 15, 1564, in the historic city of Pisa, Italy, during a period of intellectual and cultural rebirth known as the Renaissance. The world was rapidly changing, with new ideas spreading across Europe, challenging old beliefs in art, science, and philosophy. Galileo was born into a family of culture and thought. His father, Vincenzo Galilei, was a talented musician and a pioneer in music theory, particularly in the study of acoustics. Vincenzo believed in questioning tradition and using experimentation, a mindset that would deeply influence Galileo's approach to science in later years. Despite his father's progressive views on music and education, the expectations placed on young Galileo were conventional. At the age of 17, he was sent to the University of Pisa to study medicine, a respected and prosperous profession at the time. His family hoped this path would ensure financial stability and social status. However, Galileo quickly found himself uninterested in the rote memorization required for medical studies. Instead, his attention was captivated by something entirely different: the abstract beauty of mathematics and the mysteries of the physical world. The turning point came when Galileo accidentally attended a geometry lecture at the university. Instantly enthralled, he realized that mathematics had the power to describe and explain the fundamental workings of the universe, a realization that would guide him for the rest of his life. His passion for mathematics grew so strong that he began secretly studying it, devouring the works of the great Greek mathematicians like Euclid and Archimedes. Galileo's intellectual curiosity could not be contained by the confines of medical textbooks, and he soon found himself drawn to the fields of physics and mechanics. Fascinated by motion, mechanics, and the behavior of physical objects, he began conducting his own experiments. It was during this period that Galileo started questioning the long-held beliefs of Aristotle, which dominated scientific thought at the time. Aristotle's view of the universe, which placed the Earth immovably at its center, would later become one of the many concepts Galileo would challenge. After just a few years, it became clear that Galileo's heart was no longer in medicine. Much to his father's disappointment, he made the bold decision to leave medical school and dedicate himself fully to the study of mathematics and the natural sciences. Though this decision may have seemed reckless to those around him, it marked the beginning of a remarkable journey that would redefine our understanding of the cosmos. Galileo's unrelenting curiosity and drive to experiment, traits inherited from his father's willingness to challenge musical theory, set him apart from his peers. While most scholars of the time were content to rely on ancient texts, Galileo was determined to observe, test, and uncover the truth about how the universe worked. This passion for discovery soon led him to an academic career, and by the time he was in his 20s, Galileo had secured a teaching position at the University of Pisa, where he would later conduct some of his most famous experiments. This early phase of Galileo's life laid the foundation for his future groundbreaking work. His willingness to question authority, coupled with his insatiable thirst for knowledge, made him a true Renaissance man, a thinker who not only absorbed the ideas of the past, but sought to build upon them, creating a new framework for understanding the world. Before Galileo's groundbreaking discoveries, the world was deeply rooted in the teachings of the ancient Greek philosopher Aristotle. For centuries, the Aristotelian view of the universe had been accepted as fact, both by scholars and the Catholic Church. In Aristotle's model, the Earth was the fixed, unmoving center of the universe, and all the celestial bodies, the sun, the moon, the planets, and the stars, revolved around it in perfect circular orbits. According to this geocentric theory, the heavens were thought to be an unchanging realm of perfection, made of an ethereal substance unlike anything found on Earth. This idea of a flawless, immutable cosmos mirrored the theological views of the time, in which the Earth was seen as the focal point of God's creation, with humanity at the center of it all. The Catholic Church, being one of the most powerful institutions of the era, embraced Aristotle's model because it aligned with their interpretation of the Bible. Scriptural passages, such as Psalm 104, which speaks of God establishing the earth on its foundations so that it should never be moved, were taken literally. For the Church, this geocentric view not only explained the physical structure of the universe, but also reinforced their theological doctrine. Challenging this view was not merely a scientific matter, it was seen as a direct threat to the church authority and to the very belief system that governed society. Anyone who dared to question the position of the earth risked being accused of heresy, a crime that could result in imprisonment, excommunication, or even execution. But despite the dominance of Aristotle's model, not all thinkers were content with this ancient explanation. In the early 16th century, a Polish cleric and astronomer named Nicolaus Copernicus quietly began to develop a radical new theory that would forever change our understanding of the cosmos. Unlike Aristotle, Copernicus proposed that the sun, not the earth, was the center of the universe. According to his heliocentric model, the earth and the other planets orbited the sun in circular paths. This idea was revolutionary, as it directly contradicted both Aristotle's teachings and the Church's interpretations. However, Copernicus knew that publishing such a theory during his lifetime would be dangerous, so he delayed releasing his findings until 1543, just before his death. When On the Revolutions of the Celestial Spheres was finally published, it was met with a mixture of curiosity and skepticism. Some scholars saw the heliocentric theory as an interesting but largely theoretical model. Others outright rejected it, as it challenged not only centuries of scientific tradition, but also the religious views of the universe. Without the observational evidence to support his claims, Copernicus's work remained controversial and was largely ignored by the broader scientific community. Still, the seed had been planted. Copernicus had opened the door to a new way of thinking about the cosmos. His heliocentric model would later inspire Galileo, who, with the help of his telescope, would gather the proof needed to challenge the geocentric worldview once and for all. By the time Galileo came onto the scene in the early 17th century, the intellectual and religious climate was still firmly rooted in the geocentric model. The Catholic Church held immense power, and any challenge to the established order was met with fierce resistance. Yet the revolutionary ideas of Copernicus had set the stage for Galileo's discoveries, laying the groundwork for the astronomical revolution that was about to unfold. Galileo's use of the telescope would provide the empirical evidence that Copernicus lacked, but the battle between science and faith was far from over. In 1609, a seemingly small and innocuous invention would set the stage for one of the greatest scientific revolutions in history, the telescope. While the concept of using lenses to magnify distant objects was not entirely new, the world had never seen such a device used for anything beyond practical, terrestrial purposes like navigation or military surveillance. It was in the Netherlands that this rudimentary tube for seeing far was first developed, but it was still very limited in its capabilities. Word of this invention spread quickly across Europe, reaching the curious ears of Galileo Galilei, a professor of mathematics in Padua. Always eager to experiment and improve upon existing ideas, Galileo immediately recognized the untapped potential of this instrument. Within days of hearing about the Dutch telescope, Galileo set to work building his own version, but he didn't stop at merely replicating the design. Through meticulous trial and error, he improved upon it significantly. increasing its magnification from the modest 3x power of the Dutch version to a remarkable 20x power. His improvements were so profound that Galileo's telescope could now reveal details that no human being had ever seen before. What set Galileo apart from other inventors was not just his ability to improve the telescope, but his vision, both literally and figuratively. Galileo saw the potential to use this tool not just for mundane earthly tasks, but for exploring the heavens themselves. Then came the pivotal moment that would forever change the course of human history. Galileo pointed his improved telescope toward the night sky. For millennia, humans had gazed at the stars with nothing but their naked eyes, relying on myths, religious beliefs, and ancient philosophies to explain what they saw. The night sky appeared as a static, perfect dome with stars seemingly fixed in their places for eternity. But as Galileo peered through his telescope, the heavens were suddenly revealed to be far more complex, dynamic, and imperfect than anyone had imagined. Galileo's first target was the moon, and what he saw was shocking. Contrary to the widely accepted Aristotelian belief that the moon was a perfectly smooth, polished sphere, Galileo observed that its surface was rough, filled with craters and mountains. This discovery alone was groundbreaking. It shattered the long-held notion that celestial bodies were perfect and unchanging, as Aristotle and the Church had claimed for centuries. Next, he turned his telescope to Jupiter and made an even more astonishing observation. There were 4 small points of light moving around the giant planet. These were the Galilean moons, Io, Europa, Ganymede, and Callisto, objects that clearly orbited Jupiter, not the Earth. This was direct evidence that not everything revolved around our planet, undermining the geocentric model that had dominated scientific thought for so long. As Galileo continued his observations, he uncovered even more evidence that the universe was far more intricate than anyone had previously believed. He saw the phases of Venus, similar to the phases of the moon, which could only be explained if Venus orbited the sun, not the Earth. He discovered that the seemingly nebulous band of light in the sky known as the Milky Way was not a foggy cloud, but a dense collection of countless stars. Each discovery further eroded the old geocentric worldview and supported the heliocentric model proposed by Copernicus. The telescope, a simple yet revolutionary instrument, allowed Galileo to gather evidence that directly contradicted the teachings of Aristotle and the Church. It was no longer just a theoretical debate about the structure of the cosmos. Galileo had seen the evidence with his own eyes, and now the world had to confront a new reality. This moment, when Galileo first pointed his telescope to the stars, marked the beginning of a new era in science. It was the dawn of observational astronomy, a field that would forever change our understanding of the universe and our place within it. The revolution of the telescope had begun, and there was no turning back. Galileo's observations with his newly improved telescope led to a series of discoveries that shook the very foundations of science, philosophy, and religion. The first celestial body he turned his attention to was the moon, which had long been considered a perfectly smooth and polished sphere, reflecting the divine perfection of the heavens. However, what Galileo saw through his telescope was far from this idealized vision. The moon's surface was rough and uneven, marked by mountains, valleys, and craters. This was the first time anyone had seen the moon in such detail, and it shattered the long-held belief that celestial bodies were flawless. Galileo's sketches of the moon, with its jagged, cratered landscape, provided undeniable proof that the universe was not the pristine and unchanging place that Aristotle had described. The heavens were not as separate and divine as previously thought. They were filled with imperfections, just like Earth. Next, Galileo turned his gaze to Jupiter, and what he discovered there was nothing short of revolutionary. He observed 4 small points of light, what he would later call the Galilean moons, moving around the giant planet. Night after night, he tracked their positions, and it became clear these moons were orbiting Jupiter, not Earth. This was a direct contradiction to the geocentric model, which claimed that all celestial bodies revolved around the Earth. Galileo's discovery of these moons provided the first solid evidence that not everything in the universe revolved around our planet. It was a stunning revelation, further supporting the heliocentric model of Copernicus, which placed the sun at the center of the solar system. As Galileo continued his observations, he pointed his telescope toward the faint, glowing band across the night sky known as the Milky Way. To the naked eye, the Milky Way appeared as a misty, cloud-like formation, and for centuries, people had thought it was nothing more than a celestial fog. But through Galileo's telescope, the truth was revealed. The Milky Way was not a nebulous cloud, but a vast sea of countless stars, packed so closely together that they appeared as a continuous band of light. This discovery completely changed humanity's perception of the universe. It was now clear that the universe was far larger and more complex than anyone had ever imagined, filled with an unimaginable number of stars and worlds beyond our own. One of Galileo's most important discoveries came when he observed the planet Venus. As he tracked the planet over time, he noticed that Venus went through phases, much like the moon. Sometimes it appeared as a full circle of light, and other times as a crescent. This observation was impossible to explain under the geocentric model, which placed Venus between the Earth and the Sun. In that model, Venus would always appear as a crescent because of its position relative to Earth. However, the phases Galileo observed could only be explained if Venus orbited the Sun. This was yet another nail in the coffin of the geocentric theory, further validating Copernicus' heliocentric model. Galileo's discoveries didn't just add new knowledge to the scientific community, they fundamentally altered the way humans understood their place in the cosmos. No longer could Earth be considered the center of the universe, and no longer could the heavens be thought of as perfect and immutable. Galileo had opened the door to a new universe, one that was vast, dynamic, and filled with mystery. His observations were a major step forward in the scientific revolution and laid the groundwork for future astronomers like Kepler and Newton to build upon. If these discoveries are making your mind spin like the planets around the sun, why not join us on this journey through space and time? Hit the like button and subscribe to our channel to keep orbiting with us and exploring the wonders of the universe. In 1610, Galileo Galilei published a book that would send shockwaves through the scientific community and beyond, titled Sidereus Nuncius, translated as The Starry Messenger. This slim but powerful volume chronicled Galileo's groundbreaking discoveries through the use of his telescope. It was a book unlike anything the world had ever seen. In it, Galileo detailed his observations of the moon, the stars, Jupiter's moons, and Venus's phases, presenting a radically new picture of the universe. Sidereus Nuncius wasn't just a scientific report, it was a revelation, one that challenged the long-standing views of Aristotle and Ptolemy and directly threatened the Church's accepted geocentric doctrine. Galileo's Sidereus Nuncius was an instant sensation. People from all corners of Europe were fascinated by the mysterious and novel revelations it contained. For centuries, the night sky had been interpreted through ancient texts and philosophical ideas, but now Galileo was offering something no one had expected: empirical evidence. His descriptions of the craters and mountains on the moon, the 4 moons orbiting Jupiter, and the countless stars that compose the Milky Way captivated the imagination of both scholars and the general public alike. As a result, the book quickly became a bestseller of its time, attracting attention far beyond the academic world. Everyone wanted to know more about the startling new findings Galileo had unveiled. Nobles, church leaders, and intellectuals alike were eager to own a copy of this revolutionary work. However, the impact of Sidereus Nuncius went beyond mere curiosity. It deeply divided the scientific and philosophical communities. On one side, there were those who marveled at Galileo's discoveries, seeing them as undeniable proof that the universe was far more complex and vast than previously thought. These supporters, inspired by the new heliocentric ideas proposed by Copernicus, viewed Galileo's observations as the first real evidence that the Earth was not the center of the cosmos. They hailed Galileo as a visionary who had finally revealed the truth about the heavens, a truth that had been hidden from humanity for centuries. On the other side, however, there were those who met Sidereus Nuncius with extreme skepticism, if not outright hostility. Many of these critics were deeply rooted in the Aristotelian tradition and were not willing to accept that centuries of accepted knowledge could be wrong. Some argued that the imperfections Galileo observed on the moon were mere optical illusions caused by the telescope itself, and they refused to believe that celestial bodies could have flaws similar to those found on Earth. Others dismissed his findings on Jupiter's moons and the phases of Venus, claiming that the telescope, a new and unproven technology, was unreliable. For many, these discoveries posed a serious challenge to their understanding of the universe and their place in it, and they were not ready to let go of the geocentric model without a fight. The Catholic Church, too, began to take notice of Galileo's work, recognizing the potential threat it posed to their teachings. At this time, the Church still held tremendous influence over intellectual discourse, and any ideas that contradicted their interpretation of the Bible were met with suspicion. Galileo's observations, which supported Copernicus's heliocentric theory, directly challenged the Church's geocentric worldview, which placed Earth, and by extension, humanity, at the center of God's creation. Though the Church did not immediately take action against Galileo after the publication of Siderius Nuncius, the seeds of conflict had been sown. Galileo's work was now under the watchful eye of the Inquisition, and as his fame grew, so did the scrutiny of his revolutionary ideas. Ultimately, it was a book that did far more than simply catalog the stars. It was a call to question the very foundations of knowledge, to look beyond the accepted truths, and to embrace a new way of thinking based on observation and evidence. Galileo's work would go on to inspire future generations of scientists, but it also marked the beginning of his conflict with the Church, a battle that would define the rest of his life. The publication of the Starry Messenger was not just the dissemination of information, it was the spark that ignited the scientific revolution. As Galileo's fame grew and his discoveries continued to support the heliocentric model proposed by Copernicus, he found himself in direct conflict with one of the most powerful institutions of the time, the Catholic Church. The heliocentric theory, which placed the Sun at the center of the solar system with the Earth and other planets orbiting around it, was not just a radical scientific idea. It was a direct challenge to the Church's long-standing geocentric worldview, which placed Earth and humanity at the heart of God's creation. For centuries, the Church had taught that the universe was structured in a way that reflected divine order, with the Earth immovably fixed in the center, while the heavens revolved around it in perfect harmony. This view was deeply intertwined with the Church's interpretation of biblical scriptures, such as passages that describe the Earth as being set on firm foundations, unshakable and unmovable. Galileo's observations, however, told a different story. Through his telescope, he had seen the phases of Venus, the moons of Jupiter, and countless stars in the Milky Way, all of which provided strong evidence for the heliocentric model. His discoveries suggested that the Earth was not the center of the universe and that it, like the other planets, revolved around the Sun. This directly contradicted the Church's teachings, and as Galileo continued to advocate for the heliocentric model, it became clear that his work was not just a scientific challenge, but a theological one as well. For the Catholic Church, the heliocentric theory posed a serious threat to its authority. At the time, the Church was not only a religious institution, but also a political and intellectual power, with control over much of Europe's education and knowledge. If Galileo's ideas were accepted, it would mean that the Church's interpretation of the universe, and by extension the Bible, was flawed. This was not just a blow to the Church's prestige, but also a potential crack in its control over intellectual and spiritual life. The Church feared that if people began to question its teachings on the cosmos, they might also begin to question other aspects of Church doctrine. In the midst of the Protestant Reformation, which had already challenged the Church's authority, this was a risk the Church was not willing to take. In 1616, Galileo's advocacy for the heliocentric model reached a critical point. The Catholic Church officially declared the heliocentric theory to be formally heretical, as it appeared to contradict the literal interpretation of certain biblical passages. The Inquisition, the Church's powerful arm for rooting out heresy, issued a decree condemning the heliocentric theory. Galileo, whose scientific reputation had made him a target, was summoned to Rome, where he was formally warned by Cardinal Robert Bellarmine not to defend or teach the Copernican theory. Although Galileo was not yet officially censured, the warning was clear. He could continue his scientific work, but he was forbidden from publicly supporting or promoting the heliocentric model as the true structure of the universe. This warning marked the beginning of a tense relationship between Galileo and the Church. While Galileo agreed to abide by the Church's restrictions for the time being, he did so with great frustration. He believed in the heliocentric model not just as a scientific theory, but as a fundamental truth about the nature of the universe, and he was convinced that, in time, the evidence would be undeniable. Nevertheless, Galileo was cautious and avoided open confrontation with the Church, choosing instead to focus on other scientific inquiries while keeping his support for heliocentrism more private. But Galileo's silence would not last forever. Over the years, as he continued his observations and amassed more evidence in support of the heliocentric model, he found it increasingly difficult to stay quiet. Galileo believed that the Church's opposition to heliocentrism was based on a misunderstanding of the Bible. He argued that Scripture was not intended to be a scientific text, and that its purpose was to teach spiritual truths, not to describe the physical universe. In Galileo's view, God had given humans reason and intellect to explore and understand the natural world, and scientific discoveries should be seen as revelations of God's creation, not contradictions of Scripture. This belief would eventually lead Galileo into a direct confrontation with the Church, setting the stage for the famous trial that would define the later years of his life. Galileo's conflict with the Catholic Church was not merely a battle between science and religion, but a struggle for intellectual freedom and the right to question established authority. It was a clash between two worldviews, one rooted in tradition and Scripture, and the other in observation and reason. Although Galileo's discoveries supported the heliocentric model, they also set him on a collision course with an institution that was not willing to relinquish its control over knowledge so easily. The warning of 1616 was only the beginning of a much larger conflict that would soon come to a head. By 1632, Galileo Galilei, despite being previously warned by the Catholic Church not to promote the heliocentric model, found himself unable to remain silent. His observations through the telescope continued to provide compelling evidence that supported Copernicus' theory, and Galileo believed that it was time for the truth to be openly discussed. That year, he published one of his most famous works, Dialogue Concerning the Two Chief World Systems, Italian, Dialogo sopra I due massimi sistemi del mondo. That would not only become a scientific landmark, but also the catalyst for one of the most dramatic trials in history. That was structured as a conversation between three characters, Salviati, who represented the voice of Galileo and supported the heliocentric model, Sagredo, a neutral observer, and Simplicio, who argued for the traditional geocentric model of the universe. Written in Italian, rather than the usual Latin reserved for scholarly works, Galileo's book was intended for a broad audience, ensuring that even those outside of the academic elite could understand the arguments. The dialogue, was witty, accessible, and filled with scientific insights that undermined the geocentric theory. By using a conversational format, Galileo was able to present both sides of the debate while subtly but decisively dismantling the Aristotelian and Ptolemaic systems that the Church supported. However, there was a crucial issue. Simplicio, the character who defended the geocentric model, was often portrayed as foolish and rigid in his thinking. Many readers, including Church officials, saw this as an unflattering caricature of Pope Urban VIII, who had once been a supporter of Galileo but now felt betrayed by the work. Although Galileo claimed that he had not intended to mock the Pope, it was clear that the dialogue was a thinly veiled critique of the Church's position on cosmology. More than just a scientific text, the book was seen as a direct challenge to the Church's intellectual authority. To the Vatican, it was no longer just about heliocentrism versus geocentrism. It was about the integrity of the Church's teachings and the potential threat Galileo's ideas posed to its dominance. The publication of Dialogue caused and caused a firestorm. The Church, already uneasy with Galileo's growing influence, viewed the book as a public defiance of their authority. Pope Urban VIII, who had previously given Galileo permission to write on the subject as long as it remained a theoretical discussion, was outraged by what he saw as a personal insult. The Inquisition, which had previously warned Galileo in 1616 to abandon his support of Copernicus, now summoned him to Rome to stand trial for heresy. In 1633, Galileo, then nearly 70 years old, made the arduous journey to Rome, where he faced the full weight of the Roman Catholic Church's judicial power. The trial was one of the most dramatic and consequential events of the 17th century. Galileo was charged with vehement suspicion of heresy for promoting the heliocentric theory, which the Church had deemed contrary to Scripture. The proceedings were tense, and Galileo, a man who had spent his life devoted to science and reason, now found himself at the mercy of an institution that valued tradition and authority over observation and inquiry. Galileo's defense rested on a technicality. He argued that he had not explicitly advocated for heliocentrism, but had merely presented it as a hypothetical model. However, the church was not persuaded by this defense. They saw his dialogue as a clear endorsement of Copernican ideas, and they were determined to make an example of him. Facing intense pressure and the threat of torture, Galileo was forced to recant his views publicly. On June 22, 1633, in a formal ceremony before the Inquisition, Galileo knelt and declared that he abjured, cursed, and detested the heliocentric doctrine, which he had spent much of his life defending. It was a humiliating moment for the great scientist, who knew that his findings were true but had no choice but to submit to the church's demands. Legend has it that as he rose from his knees, Galileo quietly muttered, "Eppur si muove," and yet it moves, referring to the Earth's motion around the sun, a final defiant acknowledgement of the truth he was being forced to deny. Whether or not this phrase was actually spoken, it has come to symbolize Galileo's unshakable belief in the power of reason and evidence. Despite his public recantation, Galileo was sentenced to house arrest for the remainder of his life. He spent his final years confined to his villa near Florence, where he continued to write and study in secret. Though silenced by the church, Galileo's work could not be undone. The dialogue continued to circulate throughout Europe, influencing scientists such as Johannes Kepler and Isaac Newton, and laying the groundwork for the eventual acceptance of the heliocentric model. Galileo's trial was not just a conflict between a scientist and the church, it was a turning point in the struggle between reason and dogma, between observation and tradition. Although Galileo was condemned by the Inquisition, history would vindicate him. His discoveries and methods would form the foundation of modern science, and his trial would serve as a stark reminder of the dangers of suppressing knowledge. Galileo's defiance in the face of overwhelming opposition became a symbol of intellectual freedom and the pursuit of truth, even at great personal cost. Though Galileo Galilei was condemned by the Roman Catholic Church and spent the last years of his life under house arrest, his voice was never truly silenced. His work, his discoveries, and his methods continued to resonate far beyond the walls of his villa, where he lived out his final days. Legend holds that after being forced to recant the heliocentric theory, Galileo muttered the famous phrase, "Eppur si muove," and yet it moves, a quiet but powerful assertion that despite the church's denial, the Earth does, indeed, orbit the sun. Whether or not he actually spoke these words, they have come to symbolize Galileo's unshakable belief in the power of observation and truth, even in the face of persecution. His trial marked the culmination of his struggle against authority, but his ideas could not be contained by any verdict. Galileo's discoveries and methods were not just revolutionary in his own time. They laid the groundwork for centuries of scientific progress that followed. His insistence on using empirical observation and mathematical analysis to understand the natural world was a radical departure from the philosophical speculation that had dominated science up to that point. By turning his telescope to the heavens, Galileo paved the way for future astronomers like Johannes Kepler and Isaac Newton to build on his work. Kepler, whose laws of planetary motion were crucial to understanding the orbits of planets, was directly inspired by Galileo's observations. And Newton, who developed the law of universal gravitation, drew heavily from the empirical methods that Galileo pioneered. Together, these scientists would forge the modern understanding of the cosmos, where the movement of celestial bodies could be explained by natural laws rather than divine intervention. Galileo's work was more than a collection of isolated discoveries. It marked a shift in how humanity approached knowledge itself. His method of observation, experimentation, and mathematical reasoning would become the bedrock of the scientific method, which has since guided countless breakthroughs in all fields of science. Through his observations of the moon's craters, the phases of Venus, the moons of Jupiter, and the vast sea of stars that make up the Milky Way, Galileo shattered the long-held Aristotelian view of a perfect and unchanging cosmos. His telescope, though rudimentary by today's standards, opened humanity's eyes to the wonders of the universe and revealed that the heavens were far more dynamic and complex than anyone had imagined. The legacy of Galileo's telescope stretches far beyond his own time. What began as a simple instrument for magnifying distant objects became the foundation for modern astronomy. Today, telescopes like the Hubble Space Telescope and the James Webb Space Telescope, orbiting high above the Earth, continue Galileo's mission of exploration. These cutting-edge tools allow us to peer deep into the universe, capturing images of galaxies, nebulae, and stars billions of light years away. The Hubble Space Telescope, launched in 1990, has provided some of the most stunning and detailed images of the universe ever seen, helping scientists study everything from the birth of stars to the expansion of the universe. The James Webb Space Telescope, launched in 2021, represents the next generation of space observation designed to look even farther into the cosmos, examining the first galaxies formed after the Big Bang and probing the atmospheres of distant exoplanets for signs of life. Every time these modern telescopes capture an image of a distant star or galaxy, they are continuing the work that Galileo began over 400 years ago. Galileo's legacy extends not only through the tools and techniques he pioneered, but also in the spirit of inquiry that he embodied. His defiance in the face of authority, his willingness to question long-held beliefs, and his relentless pursuit of truth remain an inspiration to scientists and thinkers across the world. In the end, Galileo's battle was not just with the church, but with the limits of human understanding. He expanded those limits, showing us that the universe is knowable and that through observation and reason, we can unravel its mysteries. Today, every scientific discovery, every advancement in our understanding of the cosmos stands on the shoulders of Galileo Galilei. In many ways, Galileo's greatest contribution wasn't just his discoveries, but the mindset he helped establish. The idea that the universe is governed by natural laws that can be observed, tested, and understood. It's a legacy that continues to shape our world, from the development of modern physics and astronomy to the technological marvels of space exploration. Galileo's work serves as a reminder that the pursuit of knowledge is a timeless endeavor, one that transcends the boundaries of nations, religions, and eras. Even as the Earth continues its silent journey around the sun, Galileo's legacy moves with it, ever present in our quest to explore the stars. Galileo Galilei's legacy is far more than a collection of scientific achievements. It is a profound lesson in curiosity, courage, and the relentless pursuit of truth. Through his life, Galileo taught us to look up, not just literally toward the stars, but metaphorically as well. He showed us the importance of questioning the world around us, of challenging established beliefs when evidence and observation point to a different reality. Galileo's insistence on looking beyond the surface, on probing deeper into the mysteries of the universe, is a timeless reminder that progress is never easy and often requires defying the status quo. His discoveries didn't just change the way we understand the cosmos, they changed the way we approach knowledge itself, encouraging generations to explore, observe, and think critically. Galileo's story is one of immense bravery. At a time when challenging the accepted worldview could cost a person their reputation, livelihood, or even life, Galileo dared to stand by what he saw through his telescope. His courage in the face of authority reminds us that true progress often demands a willingness to take risks, to question what we've always been told, and to embrace the unknown. It's a message that resonates today as much as it did in the 17th century. Scientific discovery and intellectual growth require both persistence and boldness. Each time we push the boundaries of our understanding, we honor Galileo's legacy, continuing the journey he began so many centuries ago. Every time we gaze through a telescope, whether in our backyards or through advanced instruments like the Hubble Space Telescope, we are connecting with Galileo's pioneering spirit. The act of looking up at the stars, of seeking to understand what lies beyond our own world, is an act of wonder and curiosity that Galileo helped ignite. His work forever changed our view of the universe, and with each new discovery, we are reminded of the path he forged. The telescope, now an instrument of science available to everyone, from amateur stargazers to professional astronomers, remains a symbol of Galileo's lasting impact. Through it, we continue to unlock the secrets of the cosmos, following in the footsteps of a man who refused to stop asking questions. If this journey through Galileo's life and discoveries has sparked your own scientific curiosity, then you're already on the right path. There is still so much more to explore, and we invite you to continue unraveling the mysteries of the universe with us. Don't forget to hit the like button and subscribe to Exploring the Universe to join us for more incredible adventures through the history of science and beyond. Together, we'll continue to question, discover, and look toward the stars, just as Galileo did.